On this episode of The Office, the Chinese Remainder Theorem. Welcome to a typical day in the life of Jim Halpert and Pam Beasley, Dunder Mifflin's resident pranksters. Like any other day, they spend more time with each other than actually working. Today's mission, to plan their wedding reception. While in the midst of quote-unquote serious planning, they are rudely interrupted by their office nemesis, Dwight Schrute. Unable to catch on to social cues, Dwight continuously insists that the engaged couple host their wedding at Dwight Schrute's bed and breakfast. Unable to wave them off, Jim and Pam decide to do what they do best: tease Dwight. Dwight's mission is to collect enough beats for their innovative new main course. But there's a catch. Jim and Pam refuse to give him an exact number. Dwight must collect enough beats so that when split into groups of 7, there are 4 left over. When split into groups of 17, 15 beats are left over. And when split up into groups of 12, 9 beats are left over.
Dwight cannot accept defeat, so he has to set himself up for a major study session. He claims that the only way for him to power through this big of a task is with a nice plate of chicken lo mein. While searching for the number of his favorite Chinese restaurant, Sun Zi's, Dwight makes an interesting discovery. The namesake for this restaurant also made an interesting discovery: the Chinese Remainder Theorem. In his book, he delves into the interesting realm of modular arithmetic. He published a statement about the number 23. His statement went along the lines of, if split into groups of 3, 2 will be left over. If split into groups of 5, 3 will be left over. And finally, if split into groups of 7, 2 will be left over. The graphic to the right illustrates this problem. In more concrete terms, the Chinese remainder theorem can be written as a series of 2 or more congruences. For sake of simplicity, Dwight is going to learn the Chinese remainder theorem through the scope of 3 distinct congruences. The theorem states that if the moduli of each of the congruences is relatively prime, there is a unique solution modulo the product of the previous moduli. This congruence, as will be shown later, can have infinitely many solutions greater than the product of R, S, and T. Although there are many ways to approach this problem, Dwight will implement a simple method of substitution. First, Dwight converts the requirements that Pam and Jim presented him into a system of linear congruences. From the knowledge that he acquired through his unexpected discovery, Dwight knows that the congruent solution must have a modulus of 1428, which is the product of 7, 17, and 12. Now that Dwight has his Chinese food and his newfound knowledge of the Chinese remainder theorem, he can solve this congruence. To begin, Dwight converts the first congruence to a linear equation. B equals 7a plus 4. B will be the number of beats that Dwight must give to Jim and Pam. Dwight plugs this equation into the next congruence and solves for a. First, he subtracts 4 from both sides, and then he uses a form of the extended Euclidean algorithm to discover that a is congruent to 4 modulo 17. Dwight then converts this congruence into the equation a equals 17b plus 4. Doing so allows Dwight to plug this equation back into the original equation for capital B. Now the number of beats equals 119b plus 32. Finally, Dwight will substitute this new equation into the last congruence. Now, Dwight follows the same steps as he did before, and this leads him to the solution that little b is congruent to 11 modulo 12. He's on the home stretch, but Dwight cannot lose sight of the goal. After plugging in values, Dwight finally comes to a solution. The number of beats that Dwight must give Pam and Jim is 1,341. Dwight rushes over to Jim and Pam, ready to accept his prize. But Jim and Pam refuse to give him his prize. Chuckling to himself, Jim tells Dwight that he wanted 2,769 beats, not 1,341. As a result, Dwight cannot have Jim and Pam hold their wedding at Schrute Farms. Although Dwight solved the congruences correctly, he did not take into consideration the multiple possibilities of this solution. Looking back at the equation that he solved for, B equals 1428C plus 1341, one can realize that although 1341 is the minimum number of beats that Dwight must give them, there's also the common factor of 1428. We can add 1428 to each new solution because this number evenly divides all three of the factors. As a result, there are infinitely many solutions to this congruence. In order to get revenge on Pam and Jim, Dwight decides to teach them a lesson using his newfound skills. He wants to send his boss, Michael Scott, a secret message bashing the couple. The RSA crypto system can be sped up when the Chinese remainder theorem is applied. In general, the computation required to solve for the ciphertext C is relatively easy. When Michael wants to decrypt Dwight's message, it requires a lot more effort. If Michael solves for X using the Chinese remainder theorem, the algorithm is much quicker. As a matter of fact, the most difficult part is simplifying C to the power of D, which can be done by implementing Euler's phi function. And this concludes today's episode of The Office.